Hey everybody, Mrs. Calabrese here for day 2 of 7th grade math online. Really excited to see what you guys turned in last night and turned in yesterday. I'm really excited to build on that as we move forward into lesson 2 today. Just a reminder to make sure you have completed lesson 1 before you get started now with lesson 2. If you have not yet completed lesson 1, go ahead and pause here on this video. Go back into the classwork assignment from March 30th, which was Monday. Complete that assignment in that lesson, and then come on back here to lesson 2, March 31st, today. Okay. Yesterday in lesson 1, we worked on reasoning with positive and negative numbers, specifically on a number line. Today, we're going to review another really important part of 7th grade math, which is adding and subtracting rational numbers. Okay. Just a reminder before we get started, the space you're in, try to limit your distractions, right? So make sure you're in a quiet space. Anything like a TV or phone or something else that might be distracting, go ahead and make sure it's put away or on Do Not Disturb. Make sure you have some materials. You need your paper and pencil on a table, and your technology is charged and ready to go. Let's go ahead and get started and set up our notes. Today is March 31st. We are adding and subtracting rational numbers. Add and subtract rational numbers. Okay, go ahead and make your paper look like mine. So we need to start by first defining what is a rational number. A rational number is any number that could be written as a fraction. So for example, 1/2 is a rational number because you can write it as a fraction, 1/2. Also, the number 6 is a rational number because you could write it as a fraction, 6/1. Now, it's not common to write 6 as a fraction. We often just write it as a whole number, but if you can write it as a fraction, then it is a rational number. Another example is like 2.4. The number 2.4 is a rational number. I could write it as a fraction. Any ideas for how I could write 2.4 as a fraction? I know that 0.4 is 4/10. So I would write 2 4/10 or 24/10 to make that a fraction. So a rational number is really, as you are in 7th grade, any number that is positive or negative, a whole number, a fraction, or a decimal. There are some numbers you know about that are not rational, and we won't be adding and subtracting those today. Numbers that are not rational are also called irrational. You know of one really exciting irrational number, which is pi. That's a decimal number that does not terminate and does not repeat. Today, we're just working with rational numbers, so positive and negative fractions, decimals, and integers. All right, a couple of things to review before we get started. There is a set of rules for adding and subtracting positive and negative numbers that we've studied a lot in 7th grade so far. Let me find this fun feature. Yes, here we go. If I want to add numbers that are either positive or negative, I have to look at the signs in the problem. So if I'm adding two numbers, if the signs are the same or if the signs of the two numbers are different, I follow different rules. So the first question I ask myself is, are the signs the same or different? If the signs are the same, for example, I have two positive numbers that I'm adding, or I have two negative numbers I'm adding, I add the absolute value of those numbers, and then I keep the sign. So for example, 2 plus 3, the signs are the same. There's two positive numbers there. So I add the absolute value of 2 and the absolute value of 3, and I get 5. And I keep the sign of the 2 and the 3, which they were positive. Another example, -2 plus -3. The signs are the same, they're both negative, so I'm going to add their absolute values. So add 2 and 3, get 5. And then I take the sign, I keep the sign of the number. So they were negative, and this one, the answer is negative. negative 5. If the signs are different, then I follow a different set of rules. If the signs are different, I subtract their absolute values. I use the sign of the greater absolute value in my answer. So if the signs are different, I subtract and then keep the sign of the number with the bigger absolute value. So in this example, negative 5 plus 6, I see that this number is negative and this one is positive. So I'm going to subtract them. I subtract their absolute values. So 6 minus 5. 6 minus 5 is 1. You'll notice my answer is 1. That's because the number with the bigger absolute value, 6, is positive. The number with the smaller absolute value, 5, is negative, so my answer does not have that sign. It has the sign of the number with the bigger absolute value, okay? There's lots of ways to prove why this is true, and if you're interested, leave me a comment and I'll link a video for some interesting explanations, okay? Let's say I'm not doing an addition problem, let's say it's a subtraction problem. What we do in 7th grade is we change subtraction by adding the opposite. We change it to addition. That way we can follow all the rules of addition. If I see a subtraction problem like negative 4 minus 9, I'm going to change it to negative 4 plus negative 9. That's to add the opposite. We also call this keep, change, change. So keep the sign of the first number, change the subtraction to addition, and change the 9 to its opposite, negative 9. Then I'm going to follow the same rules of addition. So I see the signs are the same, they're both negative. I'm going to add their absolute values. 4 plus 9 is 13. And keep the sign, the answer is negative 13. This is another example of adding the opposite where I subtract a negative. 3 minus negative 7, keep, change, change, or add the opposite. Keep 3, change minus to plus, change negative 7 to its opposite, positive 7. So 3 plus positive 7 is 10. So again, I can follow those same rules for addition. Okay, awesome. Hopefully that was a helpful review. You're going to need all of these rules as we work through today. So I have posted this picture in the resources topic of your classwork. So to see this picture again, what you need to do is go to Google Classroom, click on the classwork tab at the top, and then find the topic that's called resources, and you'll find a post that says how to add and subtract integers or how to add and subtract positive and negative numbers, and you'll see this image as an attachment. So you can print it out, you can draw your own, or you can just go back and reference it when you need to. I also attached the video that we watched in class that a lot of you really liked. It made sense to a lot of you about the bird hopping on the number line. So you can go back and watch that one to review as well. All right, let's get started with our first practice question. Oh, one reminder actually before we start is that I just want to remind you that I'm not using a calculator on these questions because this standard will never be assessed in a calculator section of a test. Meaning if you're taking the AZ Merit or if you are taking the SATs and you see questions like these, you're never going to be allowed a calculator. That's because this standard is assessing can you add or subtract, not can you type in your calculator adding and subtracting. So I'm not using a calculator in notes today. On independent practice today, please don't use a calculator, just try it using all the rules that we talk about in this video and that amazing brain of yours. All right, now we're ready. Let's go ahead and take a minute, go ahead and solve this question. I'll go ahead and pull up a 1-minute timer and do it myself as well, and we will come back and review. You may get started as soon as I grab this timer. Here we go. All right, grab your pencil, grab your paper. 1 minute is on the clock. Go ahead. Okay, we'll come back together in about 20 seconds. I'm just finishing up. All right. So you should have had enough time. If you didn't, you can pause the video and finish up before I review my solution. All right, here's what I was thinking. I saw a subtraction problem, so just like we reviewed, I changed that subtraction to adding the opposite. So keep, change, change. You also might have noticed that in this subtraction problem, it's just like you learned in 3rd, 4th, 5th grade. This 0 and 4500ths is bigger than 0 and 3900ths. So you might have actually been able to skip this step and just realize you needed to subtract, and that's okay too. All right, in order to finish solving, I notice I have signs that are different. So I'm going to subtract the bigger absolute value from the smaller absolute value. You had to borrow in this question because 5 minus 9 I can't do using the standard algorithm. So I went ahead and borrowed from my tenths place. I took 1/10 away, so that added 10 hundredths. So my 4 became 3, so subtract 1/10, and then add 10 hundredths in. 15 minus 9 is 6. 3 minus 3 is 0. Just a reminder, because we don't often do this in 7th grade, but it's something you need to remember from elementary school, is that when we are subtracting decimals, we have to line up those decimal points. That's also true for adding decimals. I got 0 and 6 hundredths. So for my answer, that should have been C. Okay. Let's move on to the next one. For this question, I'm going to go ahead and label on my paper. It's a little bit different sized. Oops. All right, hopefully that's big enough. On my paper, I'm going to go ahead and set this up as question 2A. Okay, so skip a couple lines. Here's question 2, part A. We're going to do a few different parts of this question. Okay, question 2A, -6 plus 5 and 1/4. I want to model this question. Of course, you've done it before. You've been adding mixed numbers since you were in previous grades. But I want to just model 2 ways to do this question. There's 2 different ways that we've reviewed, and both are good. You just need to pick what makes sense to you. So before I start, let me make sure I'm in focus. There we go. Okay, I'm going to go ahead and rewrite the question, and then I'm going to move so this document camera can be actually bigger. -6 plus 5 and 1/4. Go ahead and make your paper look like mine. All right. So the first strategy that I'm going to do is actually keeping them as mixed numbers and regrouping. I like this strategy, and if you think about adding mixed numbers visually, then this strategy might work really well for you. If you think more procedurally, you'll probably like my second method better. But I'm going to go ahead and model mixed numbers first. So I see a negative plus a positive. So what that means is signs are different. I'm going to go ahead and subtract them. So I need an algorithm that will help me subtract mixed numbers. So I'm going to go ahead and set up vertical subtraction, kind of like the standard algorithm for subtraction. And I'm going to put the one with the bigger absolute value on top. So bigger absolute value is 6. So I'm going to go ahead and put 6 minus 5 and 1/4. Notice that I lined up place values. So I lined up the ones place, and then I lined up the fractions of the mixed numbers as well. Okay. I don't have anything right now next to the 6. So it's kind of like having 0/4 there. I don't have any fourths. Can I take 1/4 away from 0/4? No. So I have to borrow, just like with decimals. So I'm going to go ahead and borrow 1 whole from the 6. So that becomes 5. And I'm going to put my 1 whole into fourths. So I'm going to move it down. How many fourths are in 1 whole? Hopefully you said 4/4. I wish I could hear you. So this becomes then 5 4/4 minus 5 1/4. Okay. Now I can do 4/4 minus 1/4. Remember, I only subtract the numerators. You can think of this like a picture, right? 4 pieces of a pizza, take away 1 piece of a pizza. How many fourths are left? 3/4. And then 5 minus 5 is 0. 0 3/4. Then I need to go back into my question and follow my integer rules, right? The integer rule said if signs are different, then subtract and take the sign of the number with the bigger absolute value. The one with the bigger absolute value is negative, which means that my answer should be negative. So my answer is negative 3/4. I love this way of solving mixed number questions because it has a lot of parallels to the decimals that we just practiced in borrowing. However, there's another way to solve too that I think some of you might like as well. So I'm going to go ahead and underneath this write another way to solve. I want you to have both on your paper so that when you're doing your independent practice today, you can look back at both examples. Okay. So I'm just going to write or and then show a different strategy. Here's the question one more time. Go ahead and copy it down. Negative 6 plus 5 1/4. So this strategy, you can always add numbers by making them into improper fractions with a common denominator. So that's what I'm going to do. First things first, I'm going to make these this whole number and this mixed number both into improper fractions. So that would be negative 6/1 plus, let's see, 5 1/4 as an improper fraction. I ask myself how many fourths are in 5 wholes. I can figure that out by multiplying 4 times 5. 4 times 5 is 20. So there are 20 fourths in 5 wholes. Then I have this extra 1/4. So I can take that 4 times 5, 20, and add 1 to it. So 21/4. Excellent. That was a really quick review about changing a mixed number into an improper fraction. If you want some extra practice with that skill, then I'm going to, I attached a video from Khan Academy and some practice that you could do to help you get ready for your independent practice if you want to review converting a mixed number into an improper fraction. Okay. All right, I can't add these yet until I have a common denominator. Remember with fractions, when I add or subtract fractions, I need to have a common denominator. So I'm looking at the denominator 4 and 1, and I can make a denominator of 4 over here and then have common denominators. So that's what I'm going to do. Let's take 6/1 and make it into fourths. So keep my negative sign. I know I want fourths, and then I'm just going to write the rest of my question so I'm set up. So then the question is, how do I get 6/1 into blank over 4? I'm going to move to the side of my paper and do a little bit of extra work. 6/1 equals something over 4. Just like with proportions or equivalent ratios, I can use multiplication or division. I just need to do the same thing on the top and the bottom. 24 fourths. Does that make sense? Is 24 divided by 4 the same thing as 6 divided by 1? Yeah, isn't that cool? Okay, so this becomes negative 24 fourths plus 21 fourths. Perfect. Maybe you got a sense of relief. I did, because now I have denominators that are the same, improper fractions. I can just add their numerators now. So this numerator is a negative 24, and this numerator is a positive 24. So when I add negative 24, sorry, did I say positive? I meant positive 21. When I add negative 24 plus 21, I end up getting negative 3. So then I get an answer of negative 3 fourths. All right, so 2 strategies. Make sure you have both on your notes. 2 strategies for this question. Go ahead and label them with me. This strategy is called mixed numbers with borrowing. This strategy is especially good if you have numbers that would be hard to find an improper, common denominator for an improper fraction for. If you have a large denominator or a large whole number, that would make it more difficult to borrow. easier to make a mistake on those big multiplication problems. This one, it wasn't so bad. Second strategy, let's call it make it improper. So 2 ways you can do this question. In a few minutes, you're going to pick your favorite for a question like this one. Okay. If you need to catch up on your notes, please click pause here. Otherwise, we're going to move on to the next question. I'm going to skip a line in my notes and label this one B. Okay. Let me go back to my question. Here we go. B, 7 minus negative 0 and 9/10. I want you to try this one on your own, and then we'll come back together. I'm actually going to do it with you, so we'll come back together in just a second. Okay. All right, just 15 more seconds. All right, if you're not ready, please click pause. If you are ready, here we go. I noticed that this question was a subtraction problem, so I went ahead and did keep, change, or add the opposite. So I changed the subtraction to addition, and I changed negative 0.9 to positive 0.9. Then I'm adding 7 plus 0 and 9/10. I can do that one in my head because there's a 0 in the ones place and a 7 in the ones place. That becomes really easy. You could also use the standard algorithm. Just make sure you line up your decimals. Your decimal in 7 is just to the right. Okay, 7 and 9/10. Okay, let's move on to C. All right, here is question C. Question C, I want you to try this one on your own, but one reminder before you get started is to change both of the numbers either into fractions or into decimals. So if you want to change them both into decimals, for example, look at negative 1/2, think about what would negative 1/2 be as a decimal number, and then follow your rules for adding and subtracting decimals. Okay, I'm going to go ahead and get a timer up on the screen, and I will give you, let's say a minute and a half for this one, and I'll do it with you. Go ahead and get started. We are halfway through our time. All right, there is our time. Here's my solution. This is just the question rewritten. It was already addition, so I don't need to worry about keep, change. I like decimals for this question. I did change negative 1/2 into negative 0 and 5/10. Those two numbers are equivalent. And then I noticed that signs are different, so I'm going to subtract them and keep the sign of the number with the bigger absolute value. So 2.5, 2 and 5 tenths minus 0 and 5 tenths is 2 and 0 tenths. The number with the bigger absolute value is positive, so my answer is positive. I dropped the 0.0. If you put in your answer 0.0, you would get it correct, but it's more simplified, more simple to answer just 2, not 2 and 0 tenths. All right, last one, team. I need a fresh piece of paper, so I'm gonna get another one. Here we go. This is the last part. Okay. All right, for this one, I want you to try it again on your own, and then we'll come back and review together. Just a reminder on this one that you should pick one of those two strategies from number question 2A. So either mix numbers with borrowing or make it improper. Okay, so pick one of those two strategies. I'm actually going to put 3 minutes on the clock for you to try this one on your own. And during that time, I'm also going to turn my camera off, but I'll be doing it with you. Okay, so 3 minutes. Right now. All right, folks, we are back. I did it both ways. Remember, you could have just picked one of these ways. For the way that you didn't pick, just pay careful attention to how I thought about it, because it's helpful to know both so you can check your work. Right? This first method that I tried is the one I thought most of you would pick, which is to just make the numbers both improper fractions and then find a common denominator. So this was the original problem. My first step was to make this whole number into an improper fraction, 4/1. And then my second step was to get a common denominator. I knew that I could make both of these numbers have a denominator of 4. This one already did. And in order to make 4 over 1 have a denominator of 4, I just wrote equivalent ratios. So 4 over 1 equals, this was blank, over 4. I know that to get from 1 to 4 was times 4, so I could do the same thing in the numerator, and I have to do the same thing in the numerator. 4 times 4 is 16. So 4 over 1 is equal to 16/4. But does that make sense? Is 4 divided by 1 the same as 16 divided by 4? Yes, looks good. All right, so I can replace 4 over 1 with 16/4. That's just an equivalent fraction. And now I can add them because they have a common denominator. Right? -1 plus 16 is 15, so I should get 15/4. That is a simplified improper fraction, and I can absolutely leave my answer like this. Or I can make that improper fraction into a mixed number. To make it into a mixed number, I just figure out how many groups of 4 are in 15. There are 3 complete groups of 4 in 15, right? Because 3 times 4 is 12. And then there are 3 leftover fourths. So 3 and 3/4. Cool. If going between a whole number or an improper fraction and a mixed number is challenging for you, then I recommend this other strategy. And this other strategy is that mixed numbers with borrowing. So here's just the final example. This is just the same question rewritten. I noticed that signs were different, so I needed to subtract the one with the bigger absolute value minus the one with the smaller absolute value. So in this case, I had 4 and no fourths minus this 1/4, and there were 0 wholes there. Okay. I know that I could not do 0/4 minus 1/4 in the standard algorithm, so I needed to borrow 1 whole. So I borrowed 1 whole, and I asked myself, how many fourths are in 1 whole? I know there are 4 fourths in 1 whole. So 3 and 4/4 is equivalent to 4. I haven't changed the value at all. And then I can subtract. This is my favorite part. 4/4 minus 1/4 is 3/4, and 3 minus 0 is 3. The number with the bigger absolute value was positive, so my answer is positive 3 and 3/4. Okay. In this method, I did not have to go from mixed number to improper fraction. I didn't have to go from improper to mixed. I just kept it as proper mixed numbers. So if this method is easier for you, then choose this one on your independent practice today. Okay. Awesome. We made it through all the questions we're going to review today. I have a couple of reminders and also a preview of your independent practice that I wanted to give. First reminder, all of the problems that we did in our review today only had one operation in them. Okay. This question was a subtraction problem. This one was an addition problem. So we really didn't have to think about the order that we did operations in because every question only had one operation. So I just wanted to remind you that when you have more than one operation in the question, then follow the order of operations. The order of operations, remember, we can represent with GEMDAS, grouping symbols first, then exponents, then any multiplication and division from left to right, then any addition and subtraction from left to right. Okay. You'll see that on your independent practice today, so just make sure grouping symbols you do before you do anything else. Okay. The second thing that I wanted to remind or actually do is a preview of your independent practice. Okay. In your independent practice, question 3, the formatting is a little bit funky, so I just wanted to preview it and show you what you're supposed to be doing. For question 3, there is an expression on the left and then 3 boxes. 1 box for greater than 0, 1 for less than 0, and 1 for equal to 0. What you're supposed to do here, which I think is a little bit unclear, is you are supposed to look at this expression and figure out, is the value of that expression greater than 0, less than 0, or equal to 0, okay? This expression is also formatted really funny. It didn't fit all in the right line, and I'm not sure why that's happening. But this first one says 5 minus -5. So you're going to write down 5 minus -5, solve it, and then put an X in the box that you think is correct. So if you think this one is equal to 0, just go to this box, type X, and then move on to the next one. okay? The next expression is this one, 5 plus negative 5. So solve that, put an X in the box that shows the solution you think is true. The third one is negative 5 plus negative 5. And then the last one is negative 5 minus 5. Okay? So if you're looking at that question on your own and you're like, wait, I'm confused, just come on back to the end of this video and listen to the expressions as I say them. Okay? And then the last reminder that I had is if you, again, want to review finding a common denominator or converting between mixed and improper fractions, I linked some Khan Academy videos. You can watch those. You can see an example of those and get a little bit of practice before you complete your independent practice. Okay, your independent practice assignment is due tonight at 10 p.m., so March 31st at 10 p.m. If you want some help on your assignment, Ms. Russell will be in office hours today again at 2:15 to 3:15, so hop on using the link in the post. And then if you are doing your assignment after office hours have already happened, you can also request to join Reteach tomorrow at 10:45 a.m. So just shoot Ms. Russell a text if you know you want to be in Reteach tomorrow, okay? And then on that note, as a reminder, you are welcome to text both me and Ms. Russell anytime between 8 a.m. and 8 p.m. If it's earlier than that or if it's later than that, please don't send us a text, just do your best and then text us in one of those time windows, and we are really eager to help you out so that you are prepared, confident, and scoring really well on our independent practice. It was awesome to be with you for this lesson 2 of online learning. See you in office hours. Have a good day.